Hello, class. Welcome to the next segment in the Week 9 material. And in this next segment, we're going to be continuing our conversation about arrays. And in this segment, we're going to talk about two main things. One is one thing that you really need to watch out for when you're working with arrays. This is something that can cause a lot of confusion if you're not aware of what we're going to talk about. And the other thing that we're going to introduce is how we can actually incorporate the slice syntax that we introduced in Week 5 into our discussion on arrays. But to start off with, let's just go ahead and get some ground here. So pretty much the same exact thing that I had before. This is actually the same exact three-dimensional array that we introduced in the previous segment. And if we want to refresh our memory on what that looks like, so there's our lovely array of numbers, again, in terms of stacks, rows, and columns and whatnot. Now, one thing that we can do is we can also manipulate individual entries in our array, and we can do that very simply. We can just simply take the name of the array that we have in question, and we can say something like this. So this would be take the item that is in stack number 1, row number 1, column number 1, which if we look at our array here, this would be stack number 0, stack number 1, stack number 2. So stack number 1 here would correspond to this specific stack. So that assortment of numbers. And then out of that assortment of numbers, we want row number 1, column number 1, which would be this 13 here. And we want to set that specific entry to 50. So that's what this is going to do on line 8. We take this entry corresponding to stack number 1, row number 1, column number 1, and we set that equal to 50. So that would change this value of 13 to 50. And just to prove that, we'll go ahead and run this, and you can see this is the original array that we started with before we put this part on line 8 here. And then after that, you can see that 13, right smack dab in the middle of this stack, does in fact become a 50. So we can alter individual entries in our array very easily by just specifying which entry we want altered, and then whatever we want to change that to is just simply what we put on the right-hand side here. Now, let's actually go ahead and put this back to what we originally had. And now we're going to start. This is where we're going to actually get into the part that can be very wildly confusing and something that I really want to address and make sure I address as clearly as can be. So up here we've declared our array, which again is stored in this variable called 3dim. Now here on line 12, I'm setting a new variable equal to the original array. So again, this is the original array that we started with. Now, what I'm doing here is just like what we had before, stack number 1, row number 1, column number 1, whatever that entry is, take away that entry and replace it with the value of 50. And notice how we're seemingly applying this change to this array called new3dim, which appears to be just the array that we have up here. So we're saying take the array that's in 3dim, take that same array and put it in new3dim, and then the array that we put in new3dim, we're saying take stack number 1, row number 1, column number 1, and set that equal to 50. Okay, doesn't seem like a big deal. So here we'll go ahead and print out what new3dim looks like, and just like before, the value or the entry that we expected to be changed is in fact changed to what we put on the right hand side, the equal sign here. So that's printing out new3dim. Now, one thing you might think is, okay, we made this change to new3dim. It doesn't seem like we changed the original array, which is called 3dim. Actually, it's not quite what it seems. In fact, we can prove that. So this is the array new3dim, hence the first print statement up here. And this is the array that is in 3dim, hence the second print statement. And you can see the change that I made to this array, also that same change was made to the original array that we started with. And this seems really confusing, and the explanation as to why this is the case is really complicated, or it can be really complicated, but in the interest of keeping things as simple as possible, this is just a consequence of how the computer's memory holds on to arrays. And it turns out if you simply set an array equal to another, you kind of end up pairing those arrays together so that if you make a change to one array, you'll also make the same change to the other array. And you can see we demonstrate exactly that. We made a change to new 3dim, but it also turns out because we set new 3dim equal to 3dim, since we have this part on line 12 here, since we had that, any changes that we made to new 3dim were also made to 3dim, the original array that we started with, and we have proven that exact fact to in fact be the case. Now, with what you're trying to accomplish here, this is probably not what you want. You probably, if you're trying to make a copy of an array and put it in a new variable, you probably don't want the process of changing one array to also change what's in the other array. And that's where the copy function enters the story here. So, and that's what we're actually going to demonstrate next. So if you want to actually make a copy of one array or to make a duplicate of an array, then you want to make sure that you use the copy function to accomplish that. And if we want to, we can sort of do the same thing that we did before. So here, same modification. Stack 1, row 1, column 1, we set that equal to 50. And then we compare the original array with the new array that we had. And if what I said is true, since we're using the copy function here, what we've done is we've told the computer we don't want the change of one array to also be applied to the change of the other array. So contrast that with what we had here on line 12, when we just simply set one array equal to the other. By doing that, and only that, we basically told the computer whatever changes we want made to this array also get made to this array, which may not seem like that's what's going on, but it is, and that's something that is kind of confusing and something you want to make sure you keep sorted out when you're working with arrays. If you don't want the change of one to affect the other as well, then you want to do the same thing, but make sure you include the copy function here as well. So this is probably what you're really going for if you're wanting to make a copy of an array. You take the name of the array that you want to copy and say take that name dot copy, and that tells the computer that you want those two arrays to be completely independent of each other. You don't want a change made to one array to also be applied to the other array. And we'll actually prove that to be what's going on here. So you can see here we print out 3dim, and you can see still have the 13 right in the middle here, and then we print out new 3dim, which is the array that we modified here, and you can see now the two arrays are in fact independent of each other, and the reason why the two arrays are independent of each other is because we use the copy function here when we set one array equal to the other. And the setup is your new array is equal to the name of your old array dot copy. Make sure you include the parentheses there, and that way the two arrays will be kept separate from each other. That way if you change a value in one array, it also does not change a value that's in the other array. So that's just something you'll want to keep in mind. Again, that seems kind of confusing, but unfortunately that's a consequence of working with arrays that you definitely want to bear in mind as you're working with arrays.